Today we are going to be exploring the idea of samples of a population. So we should understand what these different terms represent. And the first term is the first word there, populations. So basically all a population is the entire group of objects or individuals. So we'll just write entire group. And so whatever our sample or our population is of, and we'll have a few different examples here, the population is the entire group. So every single one. And so if we're talking about a population of the residents of El Dorado County, it's every single person in El Dorado County. A sample is a portion or a part of the population. So it's not all of them, it's just a few of them. And oftentimes we don't want to be able to survey everybody because it's impossible to do. So what we do is we come up with a sample. And so we're going to understand now when to use a sample and when not to. So let's take a look at the first example here. It talks about a gardener wants to know how many of his 12 rose bushes have this black spot fungus. And so would we want to use a sample of his 12, or do we want to check out his whole population? And his whole population is 12. So we'll say that 12 represents the entire population. So all the rose bushes that he has is only 12. Well, since this number is small, so entire population we'll say is small. It's only 12. We'll go ahead and use the population. And so again, we're using that population rather than a sample because the group, and the group is the rose bushes, the group is small. And so again, we oftentimes will use a population if the group is small, but if the group is really large, then we'd want to go with a sample. And that's what we'll see in the next example here. So as a gardener wants to know the percentage of rose bushes in California. How many are in California? So ask yourself that. How many bushes, or how many rose bushes are in California? Well, it's probably a lot, I would say. And so my response to that would be more than I could count. More than I could count. And so if that's the case, what I would want to do is use a sample. And so a sample, as long as the sample's random, it's going to be a good sample, and you'd get a good idea of the percentage of rose bushes with this black spot fungus. So here I would use a sample. And the reason I'd use a sample, because the population is large. And so again, the key to knowing when to use a sample is if the population is large, then use a sample. If the population is small, like there's only 12, and you could check all those rose bushes, then use the whole population. Well, the next set of directions asks us to use this chart. And so let's read what it says. According to the U.S. Census Bureau, about 26% of all California residents were born outside the United States. Henry surveys a random sample. So what is a random sample? Random sample represents that each person in the sample, or in this population, has an equal chance of being selected. And so a random sample is a good sample. We always want a random sample. So each member of the population has an equal chance of being selected, and that's the key there. And of residents from 2 California cities, his data is shown on this table. And so what they want to know here, well, is the sample for city A, does it compare with the statewide percentage? Well, the statewide percentage is 26%. So we want to see, again, this is 26%. We want to see, is city A about 26%? So what are we going to do? Well, we're going to take these numbers here. 17 are born outside the United States. So what we're going to do is set up a ratio that looks like this. Born outside U.S. over the total born. And so that's the key, is it's born outside the U.S. over the total born. And we're going to see if it does equal about 26%. And so what we do is right off on the side here, I'm going to go ahead and write down 17 over 17 plus 49. So I go ahead and do that work, and I end up with a 17 still on top, but now I add the 17 and 49, and I end up with 66. So now you have to do a division problem. So you have to set up a, remember, top dog goes in the doghouse, 66 over 17. And you go ahead and work out that division problem. Let's see here. We have, it goes in, got a decimal point here, so let me fix this right here. So we bring up this decimal point, and it goes in there 2 times. And so I was seeing how many times 66 goes into 170, and it goes in there 2 times. And we end up with a 2 times 6 makes 12, and that makes 13. So we do some subtraction. Remember, to borrow, you get 8, and you end up with a 3. So we go ahead and bring down another 0, and we have 66 into 380, and it goes in there 5 times. So 5 times 6 makes 30. Makes another 30, but you add 3, and you get 33. So that goes 5 times. And so we'll just go one more time here, because we'll just round to the nearest percent. And it goes in there 7 times. 7 times 66 makes, actually I'm trying to figure out how many times 66 goes into 500. 7 times, that makes a 42. Another 42 and 4 gives me 46. And so when we do that subtraction, we do end up with a good number there. That makes an 8. You got to borrow, so that makes 9 minus 6 makes 3, and 38 would end up working. So we can move that decimal over a couple times. So we got 25.7 to start with, and that's pretty close to the 26%. So I would say, yes, it is close. We'll say close to the statewide average. And so ours was the 26% is pretty close to. That's a little approximate sign there to equal, like an equal sign, but just squiggly lines rather than straight lines. And then I didn't round to the 10th place exactly. I don't know what the next number is, but I just went that far just to see that it was close. Well, the next one, same sort of thing. So off to the side, I'll do some work there. 23 is the number of residents born outside the United States in this city. And then if we add up the total numbers, 23 born outside, 88 born inside, and we end up doing that addition, and we end up with 111. And so again, when you're doing that math, you're doing the top dog goes in the doghouse, so it's 111 on the outside, 23 on the inside. Well, I went ahead and did this division already, and it comes out to about 20.7%. And so 20.7% is a little bit further away, so we'd say that the residents born in this city is less than. So we'll say city B has less residents born outside the U.S. compared to the average. So again, the key is, when dealing with samples, sample represents a part of the population, where population is the entire group or individuals. So part 2, we'll go over some more problems that you'll see on tonight's homework.